Hi, good morning. Yesterday, I listened to a podcast by Professor Glenn Jeffrey, who is a professor of neuroscience in London, and the host was Professor Andrew Huberman, who is American. He is a professor in ophthalmology and in neuroscience. He's PhD, he's not a medical doctor. But Glenn Jeffrey, he started his talk by saying that the scientists, they do mistake, but they don't admit mistakes. But we should admit mistake because they are as important as the success in our research. This is very important point. We have to admit our mistake and learn from them. Number two, why he is saying that? Because he said, why we forget the color of the water in the sea or the ocean is blue, because the water reflect the red light and reflect the blue light, and absorb the red light and infrared light. Because there is difference between reflection and absorption. So the object, for example, water, it looks blue because it reflects the blue light, but it absorbs the red light and infrared light. While the trees, which is green, and the grass, it look green because it reflects the green light. But I have studied before that when you walk in the forest or in nature, when there are trees, green trees and green grasses, then it reflects the red light and near infrared light. And then apparently the absorption of light and reflection of light, it depends on the medium. So in the plant, they reflect the green light, but they also look green, but also because it contains the pigment chlorophyll, and also it reflects red light and near infrared light, so that it helps them for thermal regulation. They perspire like us. So the tissue of the plant is different from the water, and this is very important. So then there is another point which was discussed, is the red light. There is a red light, infrared light, which is part of the electromagnetic spectrum, because the light, he said, it is from almost zero wavelength, where the frequency is rapid and the wavelength are small. And then the light which we see, it's a band between 400 nanometer to 700 nanometer only. And this is the color of the rainbow, or if we emit the light through the glass, okay? So, but the sunlight, it could go up to 3000 nanometer, okay? Now, the red light is typically, the wavelength is between 620 to 750 nanometer. This is very important to write it down when you want to buy light, and you put it especially in the countries where there is no sunlight. Then near infrared light, which come next to it, it is it is roughly from about 750 nanometer up to around 1400 nanometer. Mid infrared light, near infrared light, it is near the red light. Then we come to mid. In the middle, infrared light range between 1400 to 3000 nanometer. Then there is far infrared light, which start beyond that, usually from around 3000 nanometer and up. So the red light is the only visible light in the spectrum, and we see it when the sun rises or the sunset. And near infrared light is just right after it. So now, near infrared light, I repeat again, is from 750 nanometer up to about 1400 nanometer. And I used to have a lamp like this one, 850 to 1300. Broke, so I bought this one, which is cheaper. This bulb is only 8 pound, and I kept this one like tabletop. So I use this, but the company, they just said near infrared light. They didn't mention the nanometer, so I'm skeptical about it. I didn't buy it. My brother bought it for me. It's very cheap. But anyway, it's better than nothing. So I don't know what wavelength. Okay, so a lot of medical research and therapies, like which is called photobiomodulation. Modulation changing, bio, it's the science of life. Photo mean light, because the quantity, the smaller quantity of the light, it is called photon. Okay, so it focuses on near infrared light because it penetrates deep into the tissue and can have various therapeutic effects. It can reduce inflammation, increase energy, improve the quality and the quantity of the mitochondria, which produce energy. So the infrared light, it passes into the tissue because it is longer wavelength, penetrate into the tissue, and it is scattered inside the body. So Professor Glenn Jeffrey, he exposed a small area in the back, and he find that the blood sugar decrease in the patient. Of course, he started his experiment on small animals, fruit bee, fruit fly bee, something like that, then mice, then human. So he said very small. So the horse, he said, how big? So he said like this. And how big? Then we come to 4 inches by 6 inches. The inch is equal to 0.5 centimeter. I wanted to bring the measurement to show you how long is the 10 centimeter. This is 1, 2, 3, as long as this one, 10. And 6, you increase it, only 2 inches, yeah, increase it 5 centimeter. And they found that the effect on the, why? Because it works on the mitochondria in the skin and will scatter through the body, and the mitochondria work as community. When you do something in one area, all the other mitochondria will respond. Of course, he is famous about his experiment. Exposed the eye to by torch 670 nanometer. So he asked him why, because he said all the research before is about that. But really what I studied from other, because I read a lot, so 670, they choose it, the other researcher, because it is the same nanometer, the wavelength in nanometer, which photosynthesis in the plant happen. The mitochondria and the chlorophyll, and how they produce the energy and produce the carbon. It produces the biomass of the universe, of the food which the animal eat, and we eat the plant, we eat the animal which ate the plant, and we are what we eat, and we are what we ate in the past. It is a chain. Okay, so now I come to, so I repeat, the color in the water and the plant is all about how they absorb light and how they reflect light. Reflection, you could say radiation, because light is a radiation. It is electromagnetic field. It is a radiation. So water, I repeat, it absorbs red light and near infrared light and infrared light quite effectively, and it tends to reflect and scatter blue light. That is why we often see water is blue, especially in large quantities in the sea, in the ocean. But on the other hand, the plant, like trees and grass, have chlorophyll, absorb mainly red and blue light for photosynthesis and reflect green light, making them appear green to our eyes. But it's also true that the plant reflects infrared light, which help them in thermal regulation and other processes. So in the oceans, the situation is different because water absorbs red and infrared light quickly, and it is scatter blue and green light. That's why the color blue-green, making the ocean appear blue or green. And this is an answer for one of the Iraqi ladies who asked me, why it looks green? Because the light is reflected, the green light is reflected. So it is all about how different wavelengths of light interact with the medium, whether it is water or plant material. So it is a bit complicated. So the near-infrared light, especially in the range between 800 to 1000 nanometer, can penetrate tissue quite effectively. And they show if they put the infrared light and they put X-ray or spectrometer, it measure, you could see, we could take like X-ray from here and we could see the veins, but we could not see the bones. Why? Because the bone absorb red light and infrared light. But the vein, we see it because it contains blood which is not oxygenated. So the infrared light, it is absorbed by the oxygenated blood, like in the arteries. Okay, this is very interesting. Okay, then there is another question, with the red light or infrared light penetrate the skull? And he said yes, because the bone of the skull, it will absorb the red light and infrared light. And now there is research about treating patients with Parkinsonism. Parkinsonism, there is an area in the brain which is called substantia nigra, which is nigra from negro, black, very black, because it contains a lot of melanin pigment in a concentrated amount. Why? Because it absorbs the light, the melanin. And it is the area which produce these cells, nerve cells, produce dopamine. So in this patient with Parkinsonism, the cells get degenerated. The mitochondria in the cell, it become weak. So it will not produce dopamine, because dopamine is produced by the mitochondria in the cell. By the way, dopamine is also produced by the cells in the gastrointestinal tract. And that's why we call the gut as the second brain, or even the first brain, because it contains a lot of nerve cells and a lot of nerve fibers. So a researcher, he put the near-infrared light on the abdomen, and in this patient with Parkinsonism, and they found that the movement, they have, in Parkinsonism, they have a lot of symptoms. But the main thing that people know is that they have like a tremor. It becomes less. Why? Because when you expose the near-infrared light to the abdomen, the mitochondria work as community, so it sends signal to the brain. But now some researchers, they make helmet, like a cap, like this cap, and then put near-infrared light to improve the patient with Parkinsonism. So I advise patients with Parkinsonism to use near-infrared light. Very effective, very safe, and they might get improved. But sometimes you don't get improvement from Monday or Tuesday. You have to continue. The main thing to get result is persistence. And I have a patient with Parkinsonism and acute myeloid leukemia, which affect the bone, and I used to expose her body to near-infrared light, 850 to 1300 in the hospital. I expose her back, her abdomen. Of course, now she is in remission. She's cured, not only because of the near-infrared light, but because of fasting and reduce blood sugar, because cancer cells feed on sugar. And then when the cancer cell have no energy, then they give her chemo in a small amount. Instead of giving 400 milligram, they gave her 50, which is 1/8 of the dose. So the side effect of the chemo is less. And when asked me about acute myeloid leukemia of her sister, so I said, let her stop sugar and carbohydrate. We change into sugar. And she said, she doesn't take rice? I said, look, I'm not joking. I'm serious. If she wants to eat rice, let her eat rice and keep the cancer. And she laughed. I said, why do you laugh? She said, because the way you answer me. I said, what are you talking about? Go and read a book, Cancer is a Metabolic Disease by Professor Thomas Seyfried. I'm not joking. When I say no sugar, no carbohydrate, but she said these patients need energy. I said, I agree with you. Energy, it could come by eating protein, organic, especially when you have cancer. You have no time for your body to deal with toxins. You have to have a clean diet, clean water, exposure to sunlight, exposure to nature to regulate your biological clock. There's no time. The body is tired. So, near-infrared light, it is very important for the health of the mitochondria. They didn't understand how it works. It works through water in the cell. The water in our cell, it's like gel. It is called the fourth phase of water. It is structured water. It is called easy water. And the body produces 300 to 500 ml of structured water. So the inner cell membrane, it is folded like a crystal. It's called the crystal. And on this crystal, the cellular respiration happens. And it is protein complex 4. Of course, I have mentioned this in my Arabic videos. I don't think I did it in English. It is 4 protein complexes, and then there is an enzyme which is called cytochrome. It will be working the nano motor. There is a motor, nano. It will rotate 360 degree, but it rotates 120 degree, emit 3 unit of ATP, which is the energy unit, which is the currency of the energy. It is the dollar of the energy in our body. Then it continue 120 degree, emit 3 unit, and then another 120 degrees. Of course, they didn't mention in the podcast, but this is from my studying the mitochondria, because I like the mitochondria because it is the origin of all diseases. If the mitochondria is not healthy, it has a program to order itself to die, and the cell will die. So in all diseases, we have a problem with the mitochondria. So how to prevent diseases is to make our mitochondria better. How to slow diseases. How to stop the disease. How to stop cancer. How to stop autoimmune diseases. How to stop diabetes. How to stop obesity. How to stop all these things which we humans are suffering from, which is called metabolic syndrome, arthritis, dementia, Alzheimer. It is go to the mitochondria. So now, okay, so I will repeat that the near infrared light, especially in the range between 800 and 1000 nanometer, can indeed penetrate tissue quite effectively. And when it reaches the cell, it can influence the mitochondria, which are the cell's powerhouse. The mitochondria rely on a molecule which is called cytochrome C oxidase. This is the enzyme. A near-infrared light can enhance its activity. So it will move the motor quicker. And this will boost the ATP production. ATP, we said it is the currency of the energy. It is the dollar or the pound or the yen or the euro. And this is the energy currency of the cell. So near-infrared light can affect the structure of water within the cell, promote better hydration, and possibly improving the function of the cellular component, including those nanomotors, which produce ATP. So in the essence, near-infrared light help to optimize cellular energy production and overall cellular function. I hope this is clear. If it is not clear, comment and I will explain it in a more simpler way. You are lucky because I started now in English, because I feel I could explain it better, because all my education in science is in English. So I feel more comfortable to explain scientific knowledge or data or information in English. But now I have to translate it to my Arabic subscribers, which are very good and they are very supportive and they enjoy to learn. Thank you and goodbye.